Unit 8 is one of the bigger ones. We'll be on aquatic and terrestrial pollution. The first one is going to be about sources and impacts of pollution. You want to be able to identify sources and describe how they impact the ecosystem, and a little bit for human health, but we're definitely going to talk about human health all on its own. Okay, before we talk about the different major sources, you want to know the difference between a point source and a non-point source. So a point source is a source that you can physically point to. You can say this is exactly where it's coming from. Maybe a smokestack, an isolated spill, a waste discharge pipe, any one of these things is the picture, but you know exactly where that pollution is coming from. A non-point source is kind of up in the air. We know generally the region, typically, but there's so many different possible sources and there's so many contributors that it's difficult to say exactly where that pollution is coming from. So maybe that's, entire cities, urban runoff, or a bunch of farms that fertilize their crops, or herbicides, or just giant areas. And it's difficult to say, who exactly is to blame. In looking at how a species is affected by a pollutant, we want to consider its range of tolerance. So range of tolerance is basically indicates at what levels can this organism be exposed to this pollutant, and where does it begin to become detrimental. Is it just a little bit detrimental, or is it really, really detrimental? When I say a little bit detrimental, is like they might still be alive, but they've been stressed out. We see like a decrease of their population, reduced reproduction, so maybe there's more sterility or reproductive issues. In extreme cases, if it's way above the range of tolerance, death. So I wouldn't say this is maybe the best graph, but it does show, like, it's not always going to be a perfect little bell curve, but it's just to show basically like what that idea is, that there's a region that they can do well in, and then a region they don't. Alright, so this is looking at pH and temperature, which probably wasn't the best for when we're talking about pollutants, but you get the idea. You're an AP, you're smart. Alright, so we're going to start by talking about coral reefs. We're going to talk more about coral reefs when we get to climate change, because it's pretty important. But just generally right now, you want to know that they've been suffering damages due to increasing ocean temperatures. That's what's going to become important in the climate change unit. But also things like sediment runoff and destructive fishing practices. We're going to talk about how sediment affects places in a few slides. Oil spills can either occur as like a really big, dramatic oil spill, like with Deepwater Horizon or Exxon Valdez. But sometimes they can just be, a bunch of little minor spills that have added up. So oils are made of hydrocarbons. These hydrocarbons can stick to the feathers of birds or for marine mammals. Sometimes components of that crude oil can sink to the bottom of the ocean. That kills bottom-dwelling organisms. It can wash up on the shore and have impacts on creatures there. It can also have, very real economic consequences to the fishing industry, tourism industry, because who wants to go to a beach that's disgusting and ugly and there's no fish? Some common strategies to clean up oil. There's containment booms. So containment booms are like giant nets, and they're designed just to slow down the spread and contain the spill. And it's not going to clean it, but it does kind of squish it all together so it becomes easier to clean. And skimmers are used to, like the name suggests, literally skim it off of the surface. It does not take oil that sinks to the bottom, though. They can also burn it. I feel like, it should be pretty obvious why this is controversial. But it does keep the oil from reaching the coast. So if it's, an extreme situation and the currents are taking it to the coast, it is, it's better to get rid of it. So, there's that. A really cool thing that they can do is use genetically modified bacteria, and it uses oil as a food source. So that's pretty cool. Okay, next, dead zones are really important to know for the AP exam. Super important. Always, always, always we're going to ask questions about this in some form or another. So dead zones, we call them dead zones, but really these should be hypoxic zones. Hypoxic just means low in oxygen. I think anoxic is the word for no oxygen whatsoever, but double check me on that. It says areas of low oxygen caused by aerobic bacteria using up all the oxygen in that water. So the reason they might do that, commonly it's because of nutrient pollution. So nutrient pollution, for instance, like nitrates and phosphates from excess amounts of fertilizer, that causes these massive algae blooms. So there's just a whole bunch of algae growing. Well, it's a living thing. Living things die, and that's just how it works. So when they do die, these aerobic bacteria come in to decompose them. They decompose these little algae, and in so doing, because they're aerobic bacteria, they need dissolved oxygen to do that stuff. So when this happens, because they're using all this oxygen, now we see that dissolved oxygen level go down. We also see this happen in areas that have a lot of like organic matter. So maybe it's sewage, or maybe it's a lot of debris from deforestation or something. So there's just something floating in the water. It's organic. This bacteria come in and do their job. So good for them. We need them. But the fact is, it's taking up dissolved oxygen, and that's not good if you're a fish or anything else that requires oxygen, which is a lot. The reason why I wanted to point out, by the way, these are actually called hypoxic zones, is that we call them dead zones because there's so much like dead fish and stuff like that. There's not a lot of life that we recognize as being important, I guess. But if you're an anaerobic organism, life is pretty cool. It's a great environment for you, but we don't really depend too much on anaerobic, creatures. We do, but I mean, like, there's not an anaerobic fish. That's what I mean. So this is just another diagram of how all that works. A really important one to know is the Gulf of Mexico. It's by no means the only one. There are a whole bunch. You can look at maps to see, more where there are. But the Gulf of Mexico is pretty important to know because this results from the fertilizers coming down the Mississippi River. So it empties out into this basin and causes algae bloom. The algae bloom then causes the dissolved oxygen to go down when aerobic bacteria munch them all up. Okay, the biological oxygen demand, or BOD, we sometimes shorten as because it's a lot of words. It's the amount of dissolved oxygen needed by aerobic bacteria to break down whatever that organic matter is in water. So if there's a lot of organic matter, it's going to be a really high biological oxygen demand. Makes sense. Well, we can plot this using an oxygen sag curve. So an oxygen sag curve looks at the amount of dissolved oxygen versus the distance from a source of pollution, and measures along with that the biological oxygen demand. So let's say there's been a bunch of sewage here, a bunch of fertilizers. Closest to that spill, we're going to see the dissolved oxygen go down because the biological oxygen demand has gone way up. There's a lot of organic stuff for this bacteria to eat, so it needs a lot of oxygen, so we're going to see the dissolved oxygen decrease. As we get further away from the spill, whatever it is, or whatever that source pollution is, then we see the biological oxygen demand decrease, and as that happens, the oxygen pops back up. Okay. Another important source of pollutants are heavy metals. Heavy metals are used all over the place, either for industry, especially mining, burning of fossil fuels. Heavy metals are an issue because they can reach the groundwater, they can impact the drinking water supply, have all sorts of negative effects for major organs, can cause cancer, a whole bunch of things. It really just depends on the different metal, but they're all bad. It could be cadmium, chromium, lead, mercury. Those are the pretty common ones. Mercury is an issue because it creates, it can be turned into methylmercury. And methylmercury, so it's done by bacteria, it does with this thing called bioaccumulation, where it doesn't break down in the in the organism. So because it doesn't break down, it accumulates in the tissue. And as we go up the food chain, we see that there's a higher and higher concentration because they're eating so much of the food that has this pollutant in it. So that's called biomagnification, and it's going to come up again. Don't worry. So I just said that. Majorly does come from coal burning power plants. That's the most common one, but not to say it's the only one. It's just as far as anthropogenic sources go, it is the biggest one. We can use something called phytoremediation to take these heavy metals out of soil or groundwater. So sometimes we use them just to transfer it from the soil, and we can then dispose of the leaves that has that heavy metal in it. Other times, just depending upon what the thing is, it can also be stabilized or destroyed in some way. But either way, it's use of plants. Litter, of course, is a pretty big one because beyond just being unsightly, it can create intestinal blockage and choking hazards for wildlife. Plastic especially can introduce toxic substances to the food chain. For instance, like BPA is a pretty commonly known one. But there are other ones. And substances that have been shown to have like a neurotoxic effect, be endocrine disruptors, things like that. So plastic sucks, like especially single-use plastic. I could go on a whole rant about plastic, but I only have about 4 minutes left before it's going to cut me off. So I just encourage you to just, look around your life. What plastic are you using? What plastic can you replace in some way? It doesn't have to be a whole lot, but anything that we can do, even just a little bit, it makes a difference. And I think that's a really important thing to get from this class, is that we're not going to fix everything, especially just as a single person. We can't. But there's always just one thing we can do to just make things a little bit better. Okay, this is a really long one. Sediment pollution is just increased sediment or dirt, soil. It's considered a pollution because it does have a negative impact on the creatures in that water. It can either affect the like a predator's ability to see. It can also get stuck in the gills of fish. Things like that. It can also increase water temperature, so we'll do that because it can cause the water level to raise, and then as the water spreads out, it increases the surface area, so there's more solar energy getting into the water. It can come from places like construction, deforestation, making artificial embankments. There's a lot of erosion in area from that. And it determines the turbidity, which is just the measure of the suspended material in water. So you have a high turbidity if there's a lot of sediment in the water, and low turbidity if there's not a whole lot. The Clean Water Act was put in place to start regulating the discharge of pollutants into surface water, especially coming from wastewater treatment, I believe. But it's just any effluent, any industrial stuff that's being released into the environment. It used to just be like, yeah, whatever, just toss it out. It's cool. Ocean's big. But now they're like, maybe not. And there's more regulations on what that water has to be like before it can just go out into the waterways. And that's it.